Okay, so this is Math099, week 2. We're talking about Venn diagrams in Math 112. Those are just visual representations of sets. So just to kind of go over again some of the things that we did in Math 112. The universe. Students often get this confused. The universe is everything that's being talked about. Okay, so as far as a Venn diagram goes, when we draw this rectangle, and we have sets A and set B here, we have those sets represented by circles. This rectangle, anything inside there is the universe, including stuff in A, in B, in both, in neither. All of that is in the universe, okay? If we talk about a region that is just the stuff inside set A, it's just inside circle A here. If we're talking about inside set B, then we're talking about just inside circle B. If we're talking about the region that's in the universe, but is in neither A nor B, that is this outer stuff. A lot of students will mistakenly call this the universe, and it's not. Well, it is. I mean, it's part of the universe, but it's not the full universe. The full universe is everything. The union, you'll recall, is one or the other or both. So the union is anything inside circle A or B or both. The intersection is the overlap. That's the both A and B. Now, if the intersection of A and B is the empty set, that means that A and B have nothing in common. So their Venn diagram would look like this. They have no overlap. Right? The complement of a region is the stuff that is not in a set. So if we write B with this little symbol right here, this little apostrophe looking thing, that's a symbol for complement. That represents the stuff that's in the universe, so it's inside the rectangle, but is not in set B. So you'll notice here I've got all this stuff shaded. Everything shaded is outside of circle B, because inside circle B is the stuff that's in set B. So the stuff not in set B is all this exterior stuff. All right? So if I look at, say, like the union here, and I didn't highlight that like I did the others, did I? So if we're looking at the union, that's anything inside A or B or both. So if that is the union, then what is the complement of the union? So what is the union's complement? Well, that's the stuff that is not in the union. Right? So this is the union. So the stuff not shaded in yellow here is all this exterior stuff. So this exterior stuff here, and I kind of got cut off down here so you can't really see, but there would be yellow. You know, it would be down here as well. That is the complement of the union. Some students think of these as being opposites of each other. And yeah, you can totally think of that. I mean, look, if you talk about here what's shaded, the complement is to shade, you know, basically flip your shading. If it's unshaded, you shade it. If it's shaded, you unshade it. Okay, so let's use some Venn diagrams to determine if two sets are equal. So let's use A union B complement, which we just did on the previous page. We know that that was all this exterior stuff, right? That was the opposite or the complement of the union. And let's compare that to A complement intersect B complement. Now, how are we going to find the intersection of these? Well, let's flip this around here, make it a little easier for me to navigate this paper. If we look at these two sets separately, I did A complement in blue. So that's everything outside of A. I don't know if you can tell, but everything outside of A was shaded in blue, and I went in this, upper right to bottom left direction. B complement I did in red, and I did it in the opposite direction. It was everything that's not in set B. So A complement is in blue. It's everything outside of set A. The red is everything not in B, so it's everything outside of set B. The intersection is the overlap of red and blue. All right, well, this one's got red right here but no blue. This one's got blue but no red. Okay, so where's the overlap? Well, it's all this outer stuff here. Because these are the same shading, the same area that's shaded, then we say that, hey, these two sets are equal. All right, so that means, so we say that the sets A union B complement and A complement intersect B complement are equal. Okay. And lastly, let's do a cardinality problem. So remember, cardinality means the number of elements in that set. Now I tried to kind of like darken this in, for set A, set B, and then the universe, because these are not things inside the set. All right, those are just labels. So don't count A, B, and U when you start counting the number of things in that set. This is just a label for set A, this is just a label for set B, and this is just a label for the universe. So if we're going to find the cardinality, we can write this as in parentheses A. That's a way of saying the number of elements in set A. So if we look at circle A or set A, how many things are in set A? Remember, don't count this. This is the label. Well, we've got a 1, a P, a 3, and a D. So we've got 1, 2, 3, 4 things. So we say that that cardinality of set A is 4. The cardinality of set B is everything inside circle B. Well, 1, 2, 3, 4, 5. Remember, don't count B. That's your label. That's not something in the set. So the cardinality of set B is 5. What about the cardinality of A intersect B? Where is that? Well, the intersection is the overlap right here. So how many things are in there? Well, 1, 2. You don't want to list out the things in there. You don't want to put 3, comma D. You want to say how many things are in that set. So there's just 2. And then the universe. Now, that's not, remember I said a lot of students make this mistake. They'll just say, oh, 1, 2, 3, 4 things in the universe. No, no, no. Everything contained inside this rectangle is in the universe. Remember, don't count A, B, and U. Those are just labels. Those are not elements in the set. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 things in there. Okay, so that was some of the highlights from week 2 with Venn diagrams, comparing Venn diagrams, cardinality, complements, things like that. So I hope that helps you with week 2 for Math 99.